Hi, so in this video I'm going to go over 10.15 chapter 2.1.1 linear patterns, rates of change, and slope. So let's just hop right into it. There's quite a few examples in this video. So this one says fill in the blanks in order to make the table of values have a linear pattern. Now remember, if we're talking about linear, we care about lines. So a constant rate of change. It's constantly going the same rate each time. And it looks like it's minusing 2 each time. So 8 minus 2, because we have 8, and then there's a gap, and then 4, 2. It looks like we're minusing 2. We can try it. Let's see. So 8 minus 2 is 6. 2 minus 2 is 0. 0 minus 2 is equal to negative 2, and then 4. And it looks like that pattern works, right? So that's that question. The table below shows the height of the building after T weeks of construction. Determine whether the pattern shown in the table below is linear. If it is, then identify the rate of change. If the pattern is not linear, enter nonlinear as the rate of change. Now, these ones, I think it's helpful to make a little mock graph and just like sort of go with it. So we'll say like this is 10. Our scale is not going to work. Because as you'll find out very quickly, we start at 0. Let me change color. We start at 0, and then we go to about 8, and we jump up to 32, and then 72, and then 128, and then 200 and 288. It looks like it goes up really quick. If it was linear, we'd be adding 8 each time, and it would look more like that. So the pattern is not linear. And then you'll type in nonlinear, no quotes. Make sure you spell it right. You can copy and paste. A university's enrollment exhibits a linear pattern. It is 27,225 students in 2009. The enrollment increases to 29,885 students in 2011. Find the average change in enrollment per year from 2009 and 2011. So this one is kind of tricky if you don't know the steps. Basically, we say, okay, how much did it change first, right? That's a good thing to start with. So we have 2,9,885 students in 2011, and we're increasing from 2,7,225. And let me quickly grab that. Okay, that gets you 2,660. So there was that 2,660 new students from 2009 to 2011. But we want to find the average change in enrollment per year. So we went from 2009 to 2010 to 2011, right? Whoops. And so that went 2 years. So we want 2,660, divide that by 2. That gets you 1,330. So the average change in enrollment from year 2009 to 2011 is going to be 1,330. This one tells us to select all of the graphs that display an increasing linear function. Now, is this increasing? No, it's going down. This one's also going down. This one's also going down. And this one is going nothing. It's not increasing or decreasing. So none of the above. Find the slope of the linear function given in the following table. Now, one thing to note is the finding the slope. That there's a formula for finding the slope, and I'll write that down real quick. Okay, so finding the slope, we have this equation: y2 minus y1, x2 minus x1, and that basically will give us the rise over 1. So if you have 2 coordinates here, we have lots of coordinates, but we'll just pick 2. We have negative 9, 13, and we have negative 8 and 12. Using our formula, we want y1. So let's say this is our 1 and our 2. So we'll have y2, which is 12, minus y1, which is 13. And then divided by, and it doesn't matter which one you make at y1 or y2, but whichever one you make y1, that will be x1. So we used y1 as 13, and so 1, and so this will be x1. x1 will be negative 9, so we'll do minus negative 9. And then we'll have negative 8 here. So that will give us I feel like I could have explained that better. I think I was confused because I used y2 minus y1. But I'm going to do y1 minus y2 because that's easier for me to say. It doesn't actually change anything. So y1 minus y2, I'm going to say this is y1, so 13 minus 12, and then you have negative 9 minus 8. Minus negative 8. So that will give you 1 over 1. Because negative 9 plus, it'd be over negative 1. Yeah. Hold on. Okay, yeah. So your slope, you get 1 over negative 1, which is exactly the same as saying negative 1. So slope is negative 1. That would be your answer. Use the slope form. Use the fact that slope equals rise over run to find the slope of the following line. Now, personally, this part's actually my favorite when we're talking about linear stuff because it's really easy for me. If it's not for you, that's totally fine. But basically, we want to find rise over run. So we're going down 2 over 1. I like to find points where it's hitting evenly. So if we're going down 2, we'll do minus 2 over 1. And that's our slope. Negative 2, 1. What you could also do is go down 4 over 2. That also works. So negative 4 over 2. And that will simplify down to 2 over 1, which is the same as negative 2, by the way. So yeah, I like this one because it's really simple to do it like with a pencil and paper or anything like that, yeah. However, if you wanted to clarify, you could pick 2 points and do the slope form, this one, finding the slope, that equation. This one says, given the points 10, negative 7 and negative 7, negative 6, find the slope of the line that passes between them. So basically, we're going to be doing the equation here. We'll say this is 1 and this is 2. y1, so negative 7 minus negative 6, and then 10 minus negative 7. That gives you negative 1 over 17, which is crazy. 1 minute. Okay, yeah, it's crazy, but it's actually correct. It's kind of weird when you get crazy fractions like this, and it makes me doubt things. I don't know if it's the same for you, but negative 1 over 17 would be our slope in this case. For the function f of x equals 4.5 plus 6, find the average rate of change between x equals 0, and x equals negative 3. Now, they're giving you this. You don't need to worry about that at all. When we're talking about average rate of change, all we're talking about is slope. And when you have slope-intercept form, which is y equals mx plus b, or f of x equals mx plus b, they're the same. Your slope or average rate of change is this m value here. So in our case, it's 4.5. Boom, easy as that. And this b is our y-intercept. I think it asks in this one. No, but this plus a constant with no x is also where the graph hits on the y. The table below indicates a relationship between the time someone has been driving and the distance they have traveled in that time. Find the average rate of change. So for this, it's easier for me to do the point thing. So 1, 54, 3, 162. Yeah. You could pick any point. So we'll do 54 minus 162 over 1 minus 3. That will give you 162, 54. Hold on. 12, 4, 8. Hold on. Okay, that gives you negative 1 over 8 over negative 2, which will give you 54. Positive 54. So the rate of change is 54. Yeah, that covers this video. If you have any questions, please let me know, and I will answer them as soon as possible. Have a good one.